Greetings everyone, and good morning. How's everybody enjoying the conference? Some really good talks yesterday, really good discussions and panels, a lot of themes around digitalization, new efforts, new technologies, how do we get ahead of things? So my talk today is going to be how we've went from what is normal to a new deviation of where we're at, right? And where we're going to tomorrow. So this presentation is really more of an informational for new folks coming in, but also for the older folks that are here that have been along for the ride, right, through all the technology that we've deployed. So moving forward, what is normalization of deviance? Normalization of deviance is a phenomenon by which individuals, groups, organizations, you, companies you work for, the vendors that are here supporting, the integrators, the maintenance technicians, that come to accept a lower, possibly new standard of performance until that standard becomes accepted and becomes a new normal. So we've seen this with cars, right? Most of the older cars that you turn on your vehicle, the key went right to the ignition, went straight to the starter. Now these are just inputs into a computer requesting these things to start, requesting the brakes to actually pump. And so a lot of the technologies that we use today have been fully digitized. So the intent of the talk today is to kind of bring you from where we were at back when to where we're at today. So a lot of this talk is formulated around Dr. Diane Vaughan, who was pivotal in creating or writing a book around the Space Shuttle Challenger and Columbia disasters. The first Challenger incident happened in 1986. I think I was 16 years old. That actually hit pretty close to home for me. I live 15 minutes away from NASA. I've been a fan of NASA for a long time, so understanding the ravelings of the sociology and the psychology around how we take things from standards and we deviate from what is normal today to how we deviate to what is accepted. And so this talk is going to cover that. But her second bullet point here is that it is a process where a clearly unsafe practice comes to be considered normal if it does not immediately cause a disaster. Now, having lived as an asset owner in a petrochemical facility, we worked around a lot of nasty things, right? And the one thing that was our saving grace was our policies, our procedures, our operations manuals, but also our safety systems. Another big piece of this is going to be the dwell time, or that time it takes for early warnings to be either misinterpreted or just maybe even neglected. And I think this industry, our industry for OT, has seen some fair warning, early warning indicators. And as Rob was talking about yesterday, I think we need to take action, or at least be aware of what we have and where we're at. Because if we don't, there could be a disaster, right?
In the fall of 1969, researchers at UCLA sent a single message from one computer to another, signaling the beginning of the internet and igniting a technological revolution. In the coming years, as computing power exploded and the price of computers fell, hundreds of millions of people connected to the internet. Now, billions of computers, code-driven devices, and people have linked together in the most complex man-made environment on Earth, a digital universe known as cyberspace. It expands every moment. Electronic impulses carrying data move at lightning speed. It takes more time for a fastball to cross home plate than it does for information to travel online from Washington, D.C. to Beijing and back. Blink, and you miss it. Dr. David Clark at MIT has been working to develop the architecture of the Internet since the 1970s.
So I tell people the 70s was this basic period, just working out the details. In the 80s, it started to scale. And people say to me, did you imagine hooking every computer in the world together? And I said, oh yes. We thought there might be 10,000 of them.
The Internet alone has grown from thousands of people in the 1980s to more than 2 billion now. There were almost 800 million smartphone users around the world by the end of 2011. Millions of other devices are connected to cyberspace as well, including industrial control systems, satellites, jet fighters, new cars. One researcher at Cisco estimates there are more than 12 billion devices connected online, a number that will soar to 50 billion in the next decade. The security of cyberspace is exceedingly difficult to ensure.
So this video is from 2011. It lines out a lot of the things that we've seen in our industry, especially from control systems, the operational technology, which, by the way, wasn't even a coined term until about 2014 when Gartner said it was so. So it has always been industrial control systems to me, having started out at a very, very early age in this, and being taught by some of the best mentors in the world that taught us, myself, for example, how to design around failure, how to design around bugs, bugs in code, bugs in control systems, bugs in safety systems. And now, for the last 2 decades, we've got a growing concern on cybersecurity. And some of the things Rob talked about yesterday are very important for us not to neglect. So that's how we got here. We started on a process and we started to migrate over. And one of the key factors is we have to know where we've started. So a lot of the control systems, and some of the ones that I got to work on early on when I was very young, working at a plant that was built in the 40s, was pneumatics. Believe it or not, this is all pneumatic computers, pneumatic to pneumatic inputs, pneumatic outputs. There are only 4 devices that are actually plugged into a power outlet in this picture, and those are for chart recorders that took pneumatic signals into digital signals or analog signals for chart recorders. It was down here, so I don't know what happened there. Okay, so that is, thank you for that, appreciate it. Should call that out a little earlier, thank you. Yeah, so the big reveal, well thank you, because it showed it down here. Anyway, so this is the controllers that we were dealing with. This is actually a site in the United States. This is in Liberal. These are my pictures, by the way. And so this is a site in Kansas that has migrated over to newer control systems. Here's also a safety instrumented system. This is on a 2-train system on an LNG facility somewhere in the world, is all I can tell you. And it is running an older application, running an older OS, and yes, those are the credentials for it. Not anymore, not after I've assessed it and given them guidance. But some key factors here is that notice the difference between picture 1 and picture 2 is that we digitized, right? We're using Microsoft Windows, we're using new control system stuff. And then this is a newer version, or the later version, this is like 2019, of an Emerson system, Emerson Delta V system, for a large chemical company in the States. And what used to take 15 people in the pneumatics picture that you saw started to go down to maybe 5 to 10 people in the digitalization front that we were going through, to having one person running 4 units at a facility, right? So that is a deviation that we've taken with technology, but we've also taken in getting into the control room and putting more responsibilities on the operator, because the technology has not only allowed us, but has also put a lot of time and constraints on that operator to be able to operate that many units. For those that have followed the Chemical Safety Board, they do a lot of analysis post-accident. So the BP Texas City incident that happened, operator was fatigued, digital systems, the mechanical fail-safes that were supposed to protect them did not protect them, due to the fact that they were never supposed to experience liquid level on their relief valves. And they did, and that went to the storm sewer, and that went to a flare, and it ignited. I have 3 siblings that work at that site. So when those things happen, it means a lot to me. So your safety matters to me, and it should also to you and your employees as well. So that's the stretch that we've went through. So in the actual first generation of these systems, the digital forefront was actually introduced in the 1980s. There were special purpose safety PLCs, and they did help improve safety, but there were still bugs, right? They did employ redundancy in voting, so there was 2 out of 3 or triple modular redundant for those that are in the safety spectrum. And there was also enhanced availability and reliability. And at the time, there was the first TUV certified sticker stamp was back in that time frame. Serial protocol was key factor there. High-level, low-level networks were used. A lot of it was even twin-ax, coaxial type networks. And the typical systems that we saw back in the day were Triconics and ICS triplex, and even the August systems. Those probably ring a bell to you, but some of them are no longer in business. And then what I want to show here is this deviation spiral, because this is the spiral. This is where I want to tie this together for you. So when we started out with pneumatics and electromechanical relays, we were right there at the forefront. When we started integrating in the actual automation of that first series of safety and even digital systems, we deviated. We didn't have major failure or major incident, so we accepted that as a new norm. And then we went into the next generation of safety systems, which were brought into the 1990s. There was companies like Moore Products, Triconics as well, Trisense Systems, which even employed higher diagnostics, more diagnostics and availability with 1 out of 2 voting or dual modular redundant, and they were cheaper than its first predecessors, right? It was also TUV certified, but here's where it started to change and scale, very similar to what the video was stating, was we started to integrate Windows OS. And it wasn't the vendors that pushed it on us. It was us, the asset owners, that were asking for it. So the vendors did what we asked. And I know because our engineering group was saying we needed something that was more simple, that we could maintain, and we were trying to go for commercial off-the-shelf technology. And there was improved integration to the distributed control systems at the time. So that was the 90s. There's some pictures there or discussions there. There was the HEMA, the High Quad 41, which I was able to work on at the plant sites that I was at, but also at the More Products Quad Log. So a lot of the systems at that time in the 1990s within this Deviation 2 still had that independence, the independence of safety system, which we were using at the time. And I don't know if you can see the laser, but we had hardwired I/O from the safety system back into the basic process controller, the DCS. Or we had a serial network that was going peer-to-peer, non-switch, non-networked. And so this was the typical norm. When we went to this, we started to go to a second deviation, which this was allowable, using Windows OS, very early in its infancy, and then we get into the very third generation of safety systems, and that is introduced in the 2000s. If you remember in the video that you watched, that's where he said it started to scale, connectivity, networks, modems, connections, all these things. And while in the 2000s, it employed highly modular and scalable, one of the key things here is it also offered tight integration into the DCS. And also advanced programming tools, some integrated even in safety technology and field bus. Systems of that, I actually worked for one of the companies was Siemens, PCS7 failsafe, right? Emerson Delta V, SIS. I'm very, very well trained in Delta V. I'm actually taking model predictive and advanced predictive training, and even Yokogawa ProSafe, which is used in LNG facilities and offshore production platforms. So that tight integration, we went from separate to integrated to even more integration, which moved us into having a standardized single engineering workstation with operator stations, which allowed us to be able to bring in this data, you collectively be able to get alarms. We didn't have to package these in data arrays anymore and send it across serially. And so this became the new norm. Again, nothing major happened. So let's start looking at what this meant for that deviation spiral in the 2000s. as we went through this new normal, there were incidents in cyber, right? There's the Olympic Games, or Stuxnet as you call it. There was the Marucci Shire where wastewater was deployed. I think that was New Zealand, right? Australia, thank you. Well, you made it, right? So those are some key things, is just letting you know we had some indicators around that. But let's look at the standards themselves. It wasn't until 1987 that there was a single paper, okay, a single paper that came out that was talking about programmable electronic systems in process. There wasn't even a standard out yet. And then in 1993, at the American Institute of Chemical Engineers, at the Congress of Process Safety, it was brought up as a guideline for automation of critical processes. Remember, these are chemicals and things of that nature that are very dangerous. So in 1996, ISA 84 came together, the application of safety instrumented systems. In 1998 to 2000, 61508 was born. There was multiple parts to that. 2003, there was the IEC 61511, which was issued. And my point here is that we were late. We were late to the party with some of these standards. And there's a reason for that too, and I'll go over it. 2010, and it wasn't until 2016, and I was talking to Sarah about this, it wasn't until 2016 that we had the first discussion around cyber, right? And even at that time, it was just, hey, do a risk assessment. It didn't tell you how, it just said you need to do a risk assessment and you need to document your vulnerabilities. In 2017, a technical report came out from the ISA, the 84, and it was really talking about different models, different terminations, integrated versus coupled. And then in 2019, even the National Fire Protection Agency started even allowing controlled and safety in the same chassis. That's huge for NFPA. That's your large-scale industrial boilers, so forth and so on. So let's talk about, we said there was cyber at the very late into the safety side, but let's look at this from the ISA and all the other standards that are out there. Because a lot of people point to them all the time, but I just want to make one thing clear. 2002 was when ISA 99, which has been the vocal point of asset owners, operators, vendors, to be able to come together and even start building out standards. So the very first one to ever come out was just terminologies and concepts, and that was in 2007. In 2009, there was actually how you can create a program, kind of like your 3-ring binder of how we do it. Like, what is our governance structure? What are we going to have in our policies and procedures? Are we even going to allow communications to an external outside network? And then as we built up, 2013 was the first time NIST was able to put something together. That was when 800-82 came out. Now remember, as these things started to scale and we started to allow technology into our processes, these standards are coming out a little bit late. So think about that deviance, right? And think about what we're trying to, I like to call Band-Aid at the same time and put precedents on. So in 2018, 2 standards came out, one which was the 2-4, which is on the integrators, what their responsibilities are for deploying and what how they touch your systems. And then the 4-1 was how your product vendors actually have a security software development lifecycle specific to the OT side, right? And so 2019, they did the component side for the components themselves. This is very structured, very similar to the 3-3 standard. And then in 2020, John Cusimano and Jim Gilson worked 7 years together to be able to come out with a risk assessment methodology for control systems. And I tell you, it's a wonderful way of actually looking at risk. And then in 2022, I think with the earlier discussion showed that there is a Rev 3 of the 800-82. And again, this is facts. These are artifacts for you to take back with you and keep so you understand where you're at in that deviation spiral. So Rob said 2017, that's when the first safety system was targeted. And that keeps him up at night, right? He said 4 years ago he talked about it on the Hill. And the one thing that he's worried about are the things, and you should be worried about it too. So that's really the stemming piece of how this is talked about is what is today's state? What are we asking for? Well, I need safety instrumented trip data. I need the statuses. Can I get those in the cloud? Whoa. You want data from the safety system in the cloud? Okay. I need data. I don't care. Need it all. We're getting ready for an AI thing, and we want to know everything. How many trips we trip in a year? I need KPI data sent to my cell phone. The same cell phone you might go on vacation with your children with, right? For that application. And then, and here's my favorite, can I remote troubleshoot the SIS, the safety systems from my hotel, anywhere in the world? Gruntled or disgruntled? So here's where we're at now, is we're in deviation 4, and these other dots that I'm painting, these are some of the things that we saw with Colonial Pipeline. Here's the things that we saw with even Toyota, for example. Those are not necessarily safety systems, but what my point is that we've had a lot of clear early warning indicators that we need to protect our systems. And then when COVID hit, we opened up a lot of channels and communications that were untraditional, and those were done with emergency management of changes that were supposed to be temporary. Even post-COVID, when I go out to sites to do assessments, those remote connections have stayed, and they've made those temporary MOCs permanent now. So some clear cases are, where are we going to be after that? After today, for tomorrow? Because we are tightly coupled. And notice I went back a few rings to show you we've been tightly coupling our systems for decades. So going back to the doctor's, psychological and how we do things, and just because we haven't had an incident doesn't mean it's not going to happen, and we need to be careful on how we deploy our technologies. So that's it. That's really the discussion and the talk is.
I think if you'd asked us back then, we would have said that it's actually quite silly for people to take units of the network that are running either critical military missions or critical infrastructure like power supply, power grid, and hook it to a public network. We said, just don't do that.
I want everybody to just think about that. Take that back with you. So I'm not telling you not to do things. I don't own your risk. You own your risk. Your company owns your risk. But you need to start challenging the things that go into your system, your designs, because this is a digital play field out there, a playground for adversaries, for criminal organizations, for even tampering and even misconfigurations. So there are some hope, and one of the things, and I know, Zach, you probably liked that very last video because I know that hits home with you. You have your CCOP, we have standards, the 62443. It takes years for standards to develop. I am telling you, find the good standard, follow that, follow the CCOP, work with your regulatory, but also start baking in security at the very forefront. Sarah touched on that yesterday, baking it in early from engineering controls, interdependencies, digital asset awareness. Dale talked about this yesterday. You're never going to know everything that you have in your environment. But I will say this, if you're designing a greenfield, it's your job to know what digital assets are going in. You better have 100% accuracy there, because if you don't, I'm going to start questioning why you're even deploying this out in my field. Secure information architecture, making sure that these things are communicating securely. I think this is what this whole project around here, this conference is about, is working to secure these systems. But we've put in a lot of risk into untraditional systems, and I think we need to question those. Dr. Magda, talking with her at dinner last night, she was talking about supply chains. There were some discussions around that. That's not going away. We need to always question supply chains, and we do need a planned resilience structure within this. And so every one of these blocks are part of cyber-informed engineering that is a national strategy in the United States funded by Department of Energy and supported by Idaho National Labs. And I can say that I've been active in helping with these 12 principles. And it's going to be these principles moving in to our next new thing. So when I say, let's get ahead of that spiral today, let's start putting this in. Let's start baking this in and then making sure that we put that into some form of a life cycle. So the future is up to you. Folks that are on the line that are watching this, it really comes down to all of us working together. Collaboration was discussed on day one. It is bright. I want to at least leave you with optimism and hope. We don't need to have an incident or an accident or a catastrophe. Accidents are preventable. And so if there is a cyber portion to that that we can do or terminate or transfer or at least identify the risk to remediate it, I think that's what we need to be at. So I want to cultivate a culture of growth where learning from past deviations becomes a stepping stone to excellence. And together we can collaborate the power of continuous improvement, forging a path towards safer, more innovation, and extraordinary achievements, right? So that's my talk for today, and hope to have some questions and answers from the audience. And there's my contact information if you ever want to reach out or connect or just bounce some ideas off of me. There's nothing, no harm, no foul for that. So with that, I'll go ahead and leave it, and thank you for paying attention.
Thank you, Mr. Ayala. Let us now invite our moderator for the session, Mr. Michael Murphy, Head of Operational Technology and Critical Infrastructure at Fortinet. Mr. Murphy, over to you.
Excellent. Thank you. That was a wonderful, insightful session. I was going to say, just for the context of this, perhaps it's beneficial for us to bring that slide up that you had on cyber-informed engineering. I think it had some wonderful pillars that certainly resonate with a lot of the conversation.
Back there.
That'd be great. So I think again, this might sound rather self-indulgent. I think one of the sayings that I tend to gravitate towards is Murphy's Law, right? Where anything that can go wrong will go wrong.
Yes.
It generally has very negative connotations. I think personally I prefer Matthew McConaughey's perspective, which is from Interstellar, Christopher Nolan's film. Anything that can happen will happen, right? And I think you touched on many aspects in which really reinforce why we need to proactively take accountability. And I think that's where a lot of the foundations that you put up earlier resonate with so many people within this room. One of the statements that I also saw that people really began to lean into was the statement with regards to, get it here, up here, Dr. Vaughan, right? So a process where a clearly unsafe practice comes to be considered normal if it does not immediately cause a catastrophe, right?
Yeah.
I think when we look at the landscape, and we look at the way that there is this sense of urgency around addressing historically neglected OT systems, how can we bring this to an audience at the forefront of their mind so that when they're getting into OT for the first time, they apply themselves in a way that's complementary to having a very down-to-earth, leveled conversation? How can we kind of reset IT people that have been within the landscape for decades, put on their engineering hat? How can we transition them to kind of almost start from scratch and apply these fundamentals you've highlighted?
So when I was at the chemical company that I worked for, one of the things that we did with our IT group was brought them into our safety meetings that we had monthly and got them exposure onto how the actual plant floor, the factories operate, and get to show that, yes, the systems that we use out there look and feel and seem like they are just IT devices, but hearing the stories and the discussions around near misses, near safety accidents, talking about scheduling and how long it takes for a batch to operate, or problems with a flare or things of that nature, getting them involved in hearing the safety aspect is really, I think, a fundamental piece, because I think that's the first start, is getting them involved. And I've seen a lot of companies here in the last 10 years that I've worked for and worked with deploy out training for not only IT, but even operators and integrators and third parties that come out to the sites, to where they get an understanding of it's more than just, hey, don't click this phishing link or that type of training. It's more of around the environment they're going to be in, right?
Perfect.
So tying it to safety is very important. Now, the talk was around safety instrumented systems, but we see a lot of systems that are just safety critical or production critical. So treat that as the same way. It's no difference. It's just understanding if it's not loss of life or a disaster or consequence, what could that consequence be? What is that high consequence event that could come out of that? So, because I get that a lot, it's like, hey, look, we're a warehouse, we've digitized, we've got all these robots and all these things going around. Well, yeah, people could get hurt possibly, but production is another key piece.
Excellent. Right? Absolutely. So I want to take this opportunity to extend the panel out. I appreciate your preliminary feedback. I would love to ask Dale Peterson to come up and take a seat, founder and program chair of S4 Events. We also have Satan Mashirova from Honeywell as well. So please come to the stage. We're keen for your expanded insights.
Thank you.
So if anyone does have any questions, we do have a QI code available, so you can directly ask the questions and I can position them towards our key panelists here. Alternatively, we also have a microphone set up in which you can ask a direct question. Maybe while some of you kind of conjure this thought and this process, I'll maybe start with Dale. You've forged an incredible community for people that have a genuine interest in OT, or alternatively have been within the OT landscape or ICS landscape for quite some time. How do you see the kind of core concepts that Marco outlined and kind of that concept of how do we make sure that that trusted norm is not a catastrophic event? How do you kind of position that to your audience, and how do you kind of raise that awareness to transition both landscapes?
Well, I'm going to take that in a slightly different direction.
Okay, I would expect nothing less. This is good.
Because I like the way you described it, how we just kind of, it became normal, this deviance. And Zach in the audience will know this very well. In the US, there's a group called the Logic, which I can't remember the acronym, but
Linking oil and gas, yeah.
Linking oil and gas, something. It's large oil and gas companies. Yeah, the project is funded by the U.S. government and national labs, the oil companies, they're all involved, all the big players. And they asked this specific question. Mm-hmm. They said, how should we secure the connection between our safety systems and our control systems? And they asked it first in like 2009, 2010. And they came up with an answer that just shocked me. They said, well, there's lots of ways you can do it. You can do it fully integrated, you can do it partly integrated, or you can do it separate. And not really any suggestion as to which way to do it. So they got a little negative feedback. They tackled it again around the middle of the last decade. And they gave a few more warnings.
Yep.
But it was still considered fully acceptable for the vendors to go out there and sell an integrated solution. Yeah. And it was just shocking. And then finally, after Triton, they took another bite at the apple. And at the third try, while they didn't say you shouldn't integrate them, the guidance was a little heavier towards you might want to be careful. So it does happen. Yeah. And this was not, we didn't look at it. We looked at it and we just did the wrong thing. So I don't know how we solve that problem. I mean, the answer is pretty simple. You do not allow a compromise of your control system to affect your safety system. I mean, it's that basic. And there are ways to export information through one-way devices. I know a large company that uses Tofino, a large oil company that uses Tofino that allows the DCS to read from the SIS, but it can't change it. So even if everything goes wrong on the DCS, the SIS is still going to do its job. So I think you identified the cause. I'm not sure what the solution is, because in the example you gave, we walked right down that path.
Yeah, we did. And so I want to capture that, because even talking to Zach earlier is even from the Logic program, just because they didn't shut it down, they had already had integrations out there. They couldn't just shut it down because there was already deployments out in the field. What was that? That would just send a shockwave, right? The other part of it too is that the people that were part of Logic as the asset owner side, not all of them bit into it. Some of them actually said, our engineering practice, our design engineering practice is, we shall have separation.
Yeah, that's like that large
Right.
oil company.
But some of them said, we'll do it.
I think you highlighted a good point, right? I mean, when we talk about disruption, we know that disruption leads to downtime. Downtime leads to revenue loss, and revenue loss can very well lead to irreversible brand damage. And that's kind of where we need to apply this all hazards approach, right, to risk. It's not just cybersecurity. It can be flooding, it can be fires. There's a range of different aspects. I'm keen to get insights from Sultan on this, because I think that there are some concepts here that are raised, and I'm interested to see how do you believe this is going to influence the processor control vendors in their roadmap for the future, in either retrofitting cybersecurity into design or alternatively embedding it? And furthermore, how does that assist with competitive advantage as well within these landscapes?
Okay, before moving to the cybersecurity risk assessment part, let's start from the history of it, yeah? So I've grown up in the city of oil and gas, basically, next to the door. So if I take back 30 years ago, so my dad was working all his life in oil and gas, and all my relatives. So I would say from process safety accident at that time were more fatalities than now. And another reason I would like to say that at that time my dad used to say never go to work for a site because you will be exposed to H2S. So which means at that time we didn't have any remote connection. And then we needed to be on the site to be exposed to the H2S in order to perform the operation. So I've been 2 years ago in the oil and gas, and I was been performing all the operation from the, we call it green site, which means we have not been exposed. It is 50 kilometers away from the site. So technology allowed us to be less exposed to the, to the dangerous sites. And another reason, at that time, we had less statistics. So for process accidents, how many fatalities were there, we have less information. And another thing I would like to point out, it has happened last year in one power utility. They have not modernized their systems, which means they haven't utilized all the new technologies out there. Then they had blackout for 3 days with minus 40. So then now they are moving to modernize their systems. So basically, it was a process accident, which means it was wear and tear, and they didn't have predictive maintenance for that. So this, if we come back to the history. Now, if we come back to the integration right now, so in terms of technologies, I'm not speaking from vendor's perspective, but in general terms, a lot of vendors provide to the asset owner's choice. So you can integrate, but if you want to integrate, you have to be smart. Like you need to integrate Modbus firewall read-only, or you need to have 2 separate applications for engineering workstation and for safety workstation to configure the safety. And then certain measure you can implement, even though you have access to the networks and you have access to the workstation, then you have access to the application, which requires 3 times, access control. Then you cannot do anything because you have mechanical key switch in order to reprogram the safety system. So you can do integration, but you have to be smart. And then coming back to your question about assessment, currently I'm doing cyber physical risk assessment for the greenfield projects and for the big greenfield project. So before defining any cybersecurity controls, they would like to first do assessment linking their cybersecurity loss, which we call it technical loss, and technical loss can be when attackers attack the engineering workstation, what can be lost? Loss of view, loss of control, manipulation of PLC, let's say. How it relates to the process safety, how it relates to the consequences, impact to the plant, and where we're getting these consequences. We're getting from the HAZOP study. So in HAZOP study, we're taking, is this system hackable? If it's hackable, we are linking to the technical loss. So this is a way how we are doing assessment in order to identify, in order to set the cybersecurity requirements during the design stage.
So yeah, that's some really good insight, and I think you highlighted that key point around what's the core driver, right? what leads to that real compelling reason to take action? Is it based on assumed risk to the business? Is it something that's been observed? And Rob Lee obviously highlights that it's valuable to look at threat intelligence associated with your industry verticals so you can apply it to your landscape. So making it tactical and making it strategic in the way that you actually evangelize within the organization. So we do have a question here from the cloud, from the crowd. Spending too much time on webinars and virtual sessions. So the key question is, how can we ensure the sustainability and effort to counteract normalization of deviance over the long term? Perhaps Marco, I'll start with you on this one.
Yeah, so the question is, how can we ensure the sustainability and efforts? Yeah, so one of the key things there over a long time is to regularly do benchmark checks around it. And Saltiana was, very clear that, you got to be smart, right? And I think we have to be smart, but we have to be aware, because, from a risk assessment side and saying, look, we've got, Tofinos, or we've got firewalls, or we've got, all these things that are digital. The amount of misconfigured Tofinos and misconfigured firewalls and misconfigured and key switches in remote program that I've seen, going back to the human aspect that this whole talk was about, of how we've deviated, if we're relying on humans ourselves to be able to do it, we've got to be able to get ahead of it. So to answer this part of it, what are we going to do long term is we need to empower the OT people in this room to know, not only be trained, but to create a culture of not only awareness, but enable them to be able to take action, to go out to the plant site, look at the cabinets, see if the key switches are truly in run, and also go out and make sure the configurations are legit and somebody from either the vendor or the integrator didn't just put in empty rule sets. The amount of times I've seen that will shock you. So how do we get ahead of it? That's what we need to do. We need to constantly check and remember to go back to our history, right? Just because you haven't had an incident doesn't mean that, especially in today's realm and the interconnectivity, that connectivity, as you saw in the video, is the common denominator in all of this.
That's excellent. It's one thing to have insights, but I think that's highly actionable. Dale, I'm intrigued for your perspective here.
Yeah,
Here we go.
You say I wanted to tackle this. A couple of thoughts on this. I think this ties in a little bit to your consequence side of the risk equation. And we talk a lot about OT needs to talk to IT, but I think almost more important is OT needs to talk to engineers. So SIS is a clear example where you have a whole different system responsible for safety. But a lot of systems out there don't have an SIS. They have soft logic. They have programming in their PLCs to prevent bad things. Or they have special devices to protect bad things. So what I would say is you need to first identify what are the really bad things that could happen. And then where the OT or the security people come in is they say, is there a cyber way that this really bad thing could happen? And so anytime you're going to make a change to your network, you got to look at that. You got to say, did I just make it easier or possible for this bad thing to happen? And if I could just give a real quick example.
Sure.
You've probably heard of Oldsmar, or if you might have heard of it. It was a water utility in Florida in the United States. The remote access got hacked, and a hacker sent the command to put in sodium hydroxide, lye, from 100 parts per million to 10,100 parts per million. So basically make the water much more acidy, and so it could actually burn people if it was delivered. Well, first of all, the PLC never should have taken that command. Sarah's top 20 PLC secure coding practices would say do not accept that. But then you might not have a pump that can deliver that much lye into the thing, but there is almost certainly a pH sensor that would detect this. But if that pH sensor is connected to a PLC, then the attacker could actually hack the PLC, program it to send that lye, and tell the sensor not to alarm and shut off the pump. So this is where, as a cybersecurity person, you have to help them think of this, because the engineer is saying, no, that'll never happen because the PLC will send the alarm. Mm-hmm. But we know that PLC can be reprogrammed, and maybe we should have a separate pH sensor hardwired to the pump that would turn it off. And yeah, we could do 100 more security controls, but I could guarantee you with that pH sensor, it's never going to happen no matter how good the hacker is.
So I think there's, I mean, this kind of stitches into, Marco, you mentioned the Maroochydore City Council incident, right? And that was where there was a contractor that was tasked with setting up all the automated systems behind the desalination and the raw sewage treatment plant. And ultimately what happened was that contractor anticipated that he would be hired as a full-time employee, which he was not. Therefore, he was highly disgruntled. And ultimately, he discovered a way that he could still radio back in to pump raw sewage directly into the Noosa River. And that affected human lives, the whole biosphere of nature as well. And I think it's one of those things, right, where we need to clearly define what is an external threat actor and what is an internal threat actor. And a lot of the time, I think we neglect what is the motivator at play against our organization. Is it because they don't necessarily agree with what it is that we're producing or delivering? Is it based on the fact that they may not ethically believe in what we're facilitating and providing? But more importantly, as we've observed recently, it's just to create disruption. It's just for the ego and the clout within their subculture or sub-syndicates. Salt, I can see down there you're kind of maybe pondering some insights that you might want to share on that.
Yeah, I would like to comment on your insider threats. I think the insider threats, when you do assessment, you have insider threat malicious with privileged access with non-privileged access, and you have non-malicious with privileged with non-privileged, already force threat actor, right? So it is very few preventative controls that we can put in place from insider threats. However, I know some sites, they have dual control. For example, for critical operations, in order to hold the pump, you need to have 2 operators to perform this action, unless these 2 operators are 2 insiders, right? And another preventative action right now with technology advancement, I'm seeing they're combining cyber access control with physical access control. How they're, right now we know our building management are smart, right? So the platform integration with the engineering workstation, it provides kind of a multi-factor authentication. This is for insider threat. And I would like to comment to the Marco's point about technology is there, but Marco, when you went out to do assessment, mostly misconfigured, or they didn't enable, or they didn't disable. So usually when you get from, let's say, the virtualization, who will do this? Who will enable the security features or continue maintain? Those are engineers who are on the ground, who doesn't have technology knowledge. They know their automation, but they don't know how to configure a VM. So from that perspective, I am moving to the future, which I see right now is that our PLC, for example, we discussed yesterday, Marco, it's getting virtualized I/O, meaning that currently the PLCs are becoming more in a cluster form, and then you can change the PLCs and upgrade the patches very easily because the I/Os are virtualized now. But who is going to manage this? So this is in the future going towards to the data center. So the control system engineers, they have their work to do in the ground, but those all patching and virtualized environment is going to be data center centralized by IT environment. It is dangerous or not, Marco, I leave it to you.
Yeah. Yeah, that turns my stomach a little bit. The fact that you can doesn't necessarily mean you should. And so, again, when it goes back to your high consequence event, I'm challenging everyone here because I don't own your risk, right? I don't, but I just, as you said earlier, just do the smart things and be repetitive there and rinse, repeat. But we've already seen that even the cloud instances can be compromised. Look at Microsoft, right? We've also seen the governments can be compromised with cloud. We've seen even technologies that are supposed to be secure today that are insecure tonight or by tomorrow with 0 days. So the only way to really get ahead of that from a risk assessment standpoint is to really push it down further into the stack from a defense in depth strategy. And as Dale was mentioning, make decisions on still getting communications, but using different forms to be able to isolate and pull that out. So another topic around the patching, I get it, But even hearing folks yesterday saying, patching, down to 2% really, it's really up to you. Again, I can't tell you, if I go out there and I say, hey, look, your stuff's out of date. Well, yeah, no kidding, it's an Infa 90 from the 1980s. It's not going to give you a lot of value. So my point is that if you're going to go into CPUs or PLCs in the cloud and just have field I/O, I wish the best for you.
So I think I'm gonna try and do the impossible, which is stitch a narrative between all of your answers and some context additionally to that. I think, and it kind of relays back to Dale's speech with regards to how we kind of tend to focus and gravitate towards a general consensus and listen to the harmony that's played. And I think it's evident that many of us have now heard a lot of talks and discussions, and it's really about, well, where are the vulnerabilities? What is the severity of those vulnerabilities? How can they be compromised? What's the avenue and pathway of least resistance? It kind of plays that story too, where we can't neglect that there are assets that are simply misconfigured and openly connected to the internet. And a good example of what we're observing within the community is where people are using tools like Shodan, for instance, where they can run a simple scan to discover OT-based assets that are publicly connected to the internet through non-authenticated credentials. So it's this interesting dynamic, right? I think it kind of plays into where the realm is gravitating towards what's physically on-prem misconfigured, what vulnerabilities may be within those assets, and then more importantly, expanding out to where the future takes us, to what Salt mentioned. So I've got another, I would say this may be a bit of a curveball with some poetic license. There's a great question here. So with the deviations that you've now mentioned in the presentation, Marco, what do you foresee is the next deviation in the industry, and how would it impact security?
Yeah, I think Sultana was very clear that new phase of approach, I think, is valuable. I think there's value there. I'm not saying a blanket turn down of not doing things of that. It just comes down to your risk tolerance. So I think the next thing is moving to everything data center driven, to where the plant site, if there is an upset, where do they go to reset the controllers? Or if the communication or the links are now down, even in your SONET ring, your primary and secondary ring, then what? How do you operate, right? So those are the kind of things I think that are in the future that we need to get ahead of now, and be selective on what we do containerize and put into cloud, but then make sure that we have on-prem fail-safe backups to be able to isolate. And even in a degraded mode, if you're critical to your country, flowing water, running power, supplying pipeline gas, you want to make sure that if that is lost, that you have not pulled out mechanisms locally for you to be able to, even in a degraded state, operate and be able to provide your product. Huge fans of that. That's something that INL has been preaching about with cyber-informed engineering, but even the CCE, the consequence-driven cyber-informed engineering, is understanding your high consequences and not necessarily fixing digital problems with digital fixes. I think that's what we've been fascinated with for the last 2 decades is, oh, there's a vulnerability, put this on top of it. Oh, there's another issue, put that on top of it. And so we just keep adding to the Jenga stack until it falls on us. So just be cognizant of that. Just find out what those high consequence issues are, focus on them, protect those with your life or their operational state. And then everything else, if you want to containerize, again, I don't own your risk, do what you have to do. But I will say that the companies like Honeywell and Siemens, they will offer you an engineering station for safety and a separate system for processing. They'll be happy to. That's revenue for them. They totally support it. It's up to you if you want to decide to do integrated control, safety, and remote access. That's the key piece, the interconnections.
I think you highlight some really good points there, and it kind of goes down to that play of maybe within the IT industry, we've gravitated towards this concept of maybe if something's hacked, we can shut it down, we can reformat it, maybe we can't connect to the network printer in another building. When we look at OT security and we're making these decisions, they have to be well informed because they directly influence our close family, our friends, and our community. Dale, I'm not sure if you'd like to add a little bit of narrative around that too.
Sure, and I have seen cases that you talk about where they're running they have the capability of running in a degraded mode if the cloud's unavailable, but they are running most of it from the cloud. And I think that's a solution worth considering because there's a lot of advantages, especially if you're talking about, these were cases where they had a lot of small sites and they just could not afford to run it the other way.
Yeah.
And they made the business case, well, if we lose the cloud, we have to be able to have some minimum capability, but 99% we're going to run from the cloud. But on this question, I would say it's a deviation that's been in progress for a while is we're deploying systems, OT systems that we don't understand and know how to maintain. So we're taking these technologies, a lot of time the vendors will bring them in, often they'll even configure them correctly, sometimes not, but you'll start out with this great system and now you have all this very sophisticated technology and no one trained on how to do it. And then they say, well, just call us if you need any support. We wouldn't have accepted that with machinery in the plants.
Right.
So we need to really be thinking about this as another component. If we're going to take the advantages of the tech, we got to pay the price to train our people and have that support capability. And I think we've deviated from that already, and it's going to bite us.
Yeah, you're absolutely right, Dale. I think that's one of the key pieces there is for the site that I was at in Houston. You know, many of the workers there that handle the control systems, the PLCs, the boiler systems, our deep well injection pumps, and the safety instrumented system, we were all within 45-minute drive of the site. So there was no need for remote access at all. So if there was an issue, we could be out on site, even if it was a 30-minute fix, be done, leave out, get 4-hour call out, call it a day. But now we've put in a lot of these systems. So one of those deviations to support what you just said is, you know, we're bringing in new technology, people don't really understand it, and we need to really be intimate with our equipment, our controls. So that goes down to that training and also empowering the employees at that level and the OT people to be empowered.
So perhaps I'll take a moment. We have a plethora of questions still coming in, which is excellent. Does anyone want to ask a question from the microphone? Is anyone intrigued to put a hand up and get in front of the audience and ask a query or a question?
Yeah, I did want to make one point on Sultana's. So the work that she's doing, which is incredible, is on a lot of really neat big CapEx greenfields where security is baked into it, and that is exactly where you're doing great work and doing it. Some of those other systems that are even not vendor or could be integrator may not be going out with that same luxury, and they're not large CapEx. And so those are the ones that we also have to be aware of. So.
Yeah, absolutely.
Any questions? Yeah, anybody in the audience, please. It's rare to have myself, Dale, Sultana, and also Michael here. This is great.
I will keep going. I think, Sol, did you want to add?
Marco, I would like to add for your consequence-driven, yeah? So when we say about remote connection, fail-safe, mechanical barrier, we need to look from industry, right? Oil and gas, let's say it has big consequence like environmental damage, fatality. But let's take about mining. Mining, we try to do, for me, I prefer unmanned, means everything is remotely controlled. But if we don't have fail-safe, let's not take about environmental damage. But what is the cost? What is the consequence there? So do we really need that there if there is not, people are not present in that place? So, so that's what from industry to industry would like to know our risk. If mining unmanned and we don't have environmental damage, unmanned means there is no person involved. This means we don't have to deploy, I think, fail-safe. Yeah. It's just my thoughts.
But have you seen the price, the sticker price on some of those big trucks? They're not cheap. Hundreds and hundreds of millions of dollars. Tires bigger than this room. So if some hacker got in there and was playing like Tonka toys,
only financial.
that would be public image would be one. Two, there'd be damage, right? Because if I'm going to get a hold of one of these, I want to drive it, right? Loss of production, loss of mining. Could impact lithium mining, for example. That could have an impact to battery builds. So you're right, there may not be loss of life, but there could be other things in your risk profile that are not tolerable.
And I think that leads into this next question from Sarah. I appreciate the question, Sarah. So how can we decide if a new technical development is normalization of deviance or actual technical progress?
I'll take that. How do we decide? How can we decide? Having the dialogue, having the collaboration. The work that you're doing currently with the German safety instrumented system company is exactly the path forward that we need to be doing, and having that dialogue from a consultant side, a subject matter side, understanding both sides of the coin of the engineering and the cyber portions. But how to tell if a development in normalization of deviance or if it's a technical progress, one of the key factors in this whole presentation was the commonality of communication and links. So if that new technology or that new development is allowing untraditional connectivity, things that are outside of your control, that should be the first trigger. That should be the first trigger to say, okay, does that trigger a review? Yes, it does. Okay, what are the impacts? What are the consequences? Okay, well, there's none. All right, well then let's make a decision as a team to say we accept it. But if 10 years down the line this comes back and it has your name on it, then you'll have to accept the fact that that normalized under your hat. And so that's why I'm empowering folks that are out there, is that if you're in control, try to make sure that you're into those discussions at the forefront. Don't accept the norm just because other people are doing it. Right.
It's a really good point, and I think there's another question here that's just come through, which I think is certainly front of mind, and that's what strategies can be used to provide security awareness training to personnel who operate and maintain these legacy OT systems. I think we've observed within many environments where you have an IT system that is accountable for any incidents that happen within the OT environment, but they've never actually stepped foot within an OT network. They've never physically touched a HMI or a PLC. And I think there's that interesting component, right, where it's getting people out on site, getting them to understand the ramifications or the bottlenecks that take place. Dale, I'm interested in your perspective here. How do you think we can re-engage?
Well, if you were at the last session yesterday, Justin, he was on the panel, and someone asked a question, how this secure by design thing that Sarah was talking about, how this will affect the users. And he said, well, if you do it right, it should make the user's life easier, right? If it's affecting the user, you're doing something wrong. It should be as transparent. And I think we have to be really careful in security that we don't fall into the trap. More and more I hear, we need everyone involved in security. Everyone plays a role. And yes, everyone plays some role, but we got to keep that role as small as possible. What we're asking them to do should be the bare minimum we could do. And I always ask, how can we lessen or decrease the burden of security on the people? So I understand this question, but this actually makes me nervous, because I think if we are going to require a lot out of every operator, engineer, technician to be successful, I think we're setting ourselves up for failure.
Yeah, I think that's definitely a powerful insight. I think that's very valid. Sultan?
Yeah, I provide security awareness training, by the way, to the field engineers on the site. So I would say, if pulling up the slide and saying, oh, cybersecurity is dangerous, it doesn't work. So if you say it's confidentiality, integrity, no, it doesn't work. If you tell ISO 62443, it doesn't work either. So how it works usually, what is mostly usable device in OT by all people, like automation, it's a USB, right? So if you pull up rubber ducky and show them do the demo and show them, then they get, I would say, they get interested. So with the demo, with showing up, they can raise awareness. Otherwise, just showing up the slides, 80% it's fail.
You know, it's interesting too, because you've visited, I'm sure, Marco even more, but I've visited a fair number of plants, and you always get the safety video at the beginning before they let you on the site. And I'm not sure what those really accomplish. You know, you have to watch them to get in, so you watch them to get in. Some of them are well done, some of them are funny, some of them are 20 years old, you know, so you see all these safety videos. And I think we just have to avoid falling into that trap too, of just saying, well, you can't touch this thing until you've watched this video. I'm not sure So you have to deal with this. It's an incredible challenge to say, I want to tell you a little bit that's real important and have that make a long-term impact. I don't have the answer. It's a really hard problem.
Yeah, so
About safety, yeah, it is the only way how they forced us to learn safety. I remember you need to pass the test. Multiple tests are not working. So they're sending HSC and they keep asking us and threatening, then you will not have permit to work. Means on the site, in order to perform anything, you need to have permit to work this way. In cybersecurity space, yeah, it's only by showing real case hands-on. Other than that, I don't have answer.
I think to answer this question, one of the big strategies that I've been successful with is just going out and working with companies and bringing the engineering and the maintenance side of it, because I started out in instrumentation and electrical before I went into the engineering aspects. And so getting someone out there, if the CISO is saying, hey, we need to do this, can you go out there and talk to the folks? Having somebody that not only understands the plant side of it, but understands their pain, right? What are the pains out there? Not enough resources. We've been asking for updates on the PLCs for a long time. We've been asking to put locks out there. Just having somebody out there on the legacy side to actually build training curriculum that fits them. That's the important part. I think that's the strategy you want, is to be able to bring someone in. And SANS has got training, ISA has training, but even formalizing training that you could come in during the safety, like the safety hour or safety monthly, and just give a 20-minute topic. And when they start hearing the words that they use and that they live by every day, and they can tie that into safe operations, that's success.
Absolutely. Yeah. So I think, I'm conscious of time. I think many of us historically, and human nature is kind of what is the pathway of least resistance, and what is the compelling driver to actually pay attention to something. Certainly, we want that to be before an incident, and I think maybe make this your moment of this being your compelling kind of initiative to take away kind of the excellent insights that have been shared. I want to take a moment, maybe a quick couple of takeaways from each of you for the audience, and what could be that compelling driver for them to take forward after this session and as they head back into the real world. Maybe Dale, yeah?
Yeah,
Okay, I'll start with you.
Just, one of the things is, and hopefully the presentation was insightful to you. Again, I'm just cheering from the sidelines, making points, making you aware. Sarah said this yesterday in her presentation, it's okay to say no, right? So if there's a challenging digitalization effort that just doesn't seem right, or there's questions around safety, it's okay to say no, but we're going to do it securely or do things in an effective manner. But now that you've seen the presentation, now that you've understood that we have been deviating for decades now, and so there are probably some in here that are still really new to this, but one day you're going to be in charge of the field side, right, of operations, maybe for the whole company that you're at. And so I challenge you from this is just go out there and spot things that don't seem right and make effective change, and work with vendors, because they're there to definitely help in that strategy, and just set the expectations up front that this is what we're going to do. Here's our new design, or here's our design engineering practice, and help us, digitize this.
Excellent, thank you. Dale.
I would just thank Marco for this new term, normalization of deviance. I got to think about that. I think there might be, I'll probably steal it in an article sometime, and I'll give you credit, though. But I got to think about that. I think that's something we really have to keep an eye out for, because it's this creeping over time that you just don't notice that is really something to think about. I guess just from my point is, and it's a little bit of a throwback to last year's, I would just really encourage you, if you are on the OT side, to work closely with your engineers and understand what they think is going to stop the really bad thing from happening, and make sure that some cyber incident can't get rid of that protection or that safety that they're counting on, that they have full confidence in. You might need to do a little demo, you might need to show them something, but I'd encourage you to look that way.
Yeah, I do agree with Dale. Focus on your worst case scenarios. And the second thing, we are, progressing in technology, will not go backwards anyway. So for example, today Fortinet showed very cool technology. Okay, you got it, but who is going to maintain it? So this is, you have to think about workforce.
Yes. I just want to finish with one thing. This has been a burning desire for a long time, especially on the safety side. For those that are new to OT or that are dealing with OT, is that one of the questions you'll want to ask your engineers, if you just don't know or just want to know, challenge them and say, these emergency shutdown buttons that we have, are those inputs to the safety PLC? Are these inputs, or do these go back to direct motor contactors? And if they say, no, that ESD button, that emergency shutdown button, that one, they all feed into the SIS, which is configurable, which is smart, and in the exact systems that we're talking about here. What I want you to at least inspire them to think about is that if you go and you push that button and it's no longer there, it's no longer an option, you're just pushing a button for the sake of pushing it and nothing is shutting down, that's what needs to go into the engineering mindset head. Because many of the installations I've seen to date, since about 2008, 2010, those emergency shutdown buttons go straight in as inputs only, making a request. I'll leave you with that. Ponder on that, think about that, have dialogue with your teams.
Very good. Excellent. Let's take a moment to thank our panelists for sharing some wonderful insights. Thank you so much. And
Thank you.
indeed, thank you.
Thank you, Michael.